In the second lecture of linear algebra, we shall deal with the following. Now, how can we represent a system of linear equations in the form of a matrix? What is a coefficient matrix? What is an augmented matrix? How to obtain the echelon form as well as the reduced echelon form? And once we do that, how do we identify the pivot elements as well as the pivot columns? Now, let's begin with the set of linear equations as shown here. So I have three equations with three variables x1, x2, x3. Now this given set of or system of linear equations can be represented in the form of a rectangular array called as the matrix. Now if I represent all the coefficients of the variables in the form of a matrix, we get the coefficient matrix. Now I have the coefficient of x1, which is 1, x2 is -2, x3 is 1, and then I have the coefficient of x1 here is 0, x2 is +2, x3 is -8, here it is -4, 5 and 9. Now if I represent the coefficients of all the variables in the form of a matrix, the matrix what we get is referred to as the coefficient matrix. So this is the coefficient matrix. So here in this case, the coefficient matrix is a 3 cross 3 matrix. But along with the coefficient matrix, if I also include the RHS, wherein I have 0, 8 and -9. Now this becomes the augmented matrix. So here the coefficient matrix is of order 3 cross 3, but the augmented matrix has 3 rows and 4 columns. This is of order 3 cross 4. So now we are very clear with the coefficient matrix as well as the augmented matrix. Now the matrix which only includes the coefficients of all the variables is the coefficient matrix. And if I include all the elements which includes the coefficients of the variables as well as the RHS, which represents the B terms, so then we get the augmented matrix. Now given a matrix, in order to find the solution, now here I have three equations and I have three variables. To find the solution, meaning that I need to find the value of x1, x2 and x3. To find the solution, if I represent this entire matrix in the echelon form, or more specifically in the reduced echelon form, it becomes very easy for me to find the solution. So how do I get the echelon form of a given matrix? We shall see that. Now how do I convert a rectangular matrix into an echelon form, or it is specifically called as row echelon form? So there are three important points which we need to remember. The echelon form of any rectangular matrix or a square matrix. So we refer to a rectangular matrix in general. So there are three specific points which we need to remember, which you can see on your screen. All the non-zero rows are above any rows of all zeros. Point 2, each leading entry of a row is in a column to the right of the leading entry of the row above it. And 3, all entries in a column below a leading entry are zeros. Now let us see the representation of the echelon form of a matrix. Now I have the first column. Say this is the leading entry of the first row. So below the leading entry, all the other entries are 0. All entries in a column below a leading entry are zeros. So this is the third point. Next, each leading entry of any row is in a column to the right. So this is the first leading entry. The next leading entry will be to the right of the previous leading entry. So this leading entry is in a column which is to the right of the first column, isn't it? So here I have to the right of column 1, this becomes the leading entry and all the elements below the leading entry are 0. The element above the leading entry can be non-zero. And what about the first point? All the non-zero rows are above any rows of all zeros. So let's assume that these are non-zeros, which are indicated by stars, and all the rows which are completely 0 are below the non-zero rows. So these are the 3 points which we need to remember. To be very specific, if I need to convert the echelon form to a reduced echelon form, we'll take examples and we shall see how we can convert a rectangular matrix to an echelon form and then from the echelon form to reduced echelon form. But here I am just explaining it in general. What is reduced echelon form? In reduced echelon form, all the leading entries are 1. So here I have 1, the remaining points are 0, the remaining elements are 0. So I need to have all these three, the first 3 points, which have to be observed even for reduced echelon form. And next, the leading entry is 1, and the rule is the leading entry is the only non-zero entry in its column. So this element, which is the leading entry, should be 1. And I should not have a non-zero element here. So even this should be 0. And I can have other elements. So these are the leading entries which are 1. And if I have a leading entry in any column, that should be the only non-zero entry. So these are the 2 extra points wherein I convert the echelon form to reduced echelon form. So let's take a few examples and we shall see how to obtain the echelon form and reduced echelon form. And what about the pivot elements? These positions where we have the leading entry are called as pivots, and the column where we have the pivots become the pivot columns. So column 1 and column 2 represent the pivot columns, and these would be the pivot elements. So let's take a few examples. Consider a rectangular matrix of order 3 cross 4. I have to get the echelon form and then the reduced echelon form. Now how do we proceed? Observe the first row and let's assume that this is the leading entry here. Now if this is the leading entry, all the elements below the leading entry should be 0. Now how do I do that? We have to perform row operations. Now what are the row operations which have to be performed? Row 2 is nothing but row 2 minus 2 times row 1. So if I multiply row 1 by 2 and if I subtract row 2 minus twice row 1, if I perform this operation, I get a 0 here. Now similarly, I observe that if I perform R3 minus 3R1, multiply row 1 by 3 and then perform R3 minus 3 times R1, so this term becomes equal to 0. So I'm only focusing on making these 2 elements 0. So here we get 1, 2, 4 and 8. So remember, row 1 remains unchanged. R2 minus 2 times R1, so 2 minus 2 is 0. 4 minus 4 is 0. I have multiplied row 1 by 2. Now 6 minus 8 is minus 2. 8 minus 16 gives me minus 8. Now let me perform this operation. 3 minus 3 is 0. 6 minus 6 is also 0. 9 minus 4 into 3, which is 12, gives me minus 3. And 12 minus 3 into 8, which is 24. So 12 minus 24 gives me minus 12. So finally we get this matrix. Now this is the leading entry and the next leading entry would be this element. Now all the elements below the leading entry should be 0 here. Now can I multiply the second row with 1 by minus 2? Then I would get 1 and 4 here. Similarly, here I find that row 3 is a multiple of 3. So again multiply row 3 with 1 by minus 3. Now if I do that, we get the following: 1, 2, 4, 8. So the second row becomes 0, 0, 1 and 4 and 0, 0, 1 and 4. Now what do we observe? We observe that the second and the third row are one and the same. So perform the row operation. R3 is R3 minus R2, because this element has to be made 0 and this is the leading element. So we have 1, 2, 4, 8, 0, 0, 1, 4, 0, 0, 1 minus 1 is 0, 4 minus 4 is 0, and this is the echelon form. So we observe that all the non-zero rows are below the 0 rows. So you have row 3 which is 0, and you have the non-zero rows, and each leading entry is, so you have a leading entry here and all the elements below the leading entry are 0. This is the leading entry, all the elements below this leading entry is 0, and we find that the next leading entry is to a column to the right of the first leading entry, right? So each leading entry of a row is in a column to the right of the leading entry of the row above it. So this is echelon form. Now how do I convert this? How do I get the reduced echelon form? In reduced echelon form, of course the leading entry should be 1. It is already 1, but I find that here in column 3 this should be the only non-zero element. So I need to make this 0. This element has to be made 0 here if I have to get the reduced echelon form. So what do? I perform R1 is R1 minus 4 times R2, right? So multiply row 2 by 4 and perform R1 minus 4 times R2. So 4 minus 4 would give me 0 there. So I have 1, 2, 0. So here 4 minus 4 is 0, and similarly here 8 minus 16 gives me minus 8, and then 0, 0, 1, 4, and then you have 0, 0, 0, 0. So 1, 2, 0 minus 8, 0, 0, 1, 4, 0, 0, 0, 0. So this is the reduced echelon form. So make a note, this is the echelon form, and this happens to be the reduced echelon form. So in reduced echelon form, all the leading entries are 1. Now it so happens that even in the echelon form for this matrix, we find that the leading entries are 1, but it need not be so. And in the reduced echelon form, if I consider the column where you have the leading entry, that is the only non-zero element. So observe here, this is the only non-zero element, and even here this is the only non-zero element. Now what about the pivot and pivot column? A pivot position in a matrix is the location that corresponds to the leading one in the reduced echelon form. Now this is where you have 1. So this becomes a pivot. And again here, this again becomes a pivot. So wherever you have the leading entry, that is the pivot. And the column, so this is column 1 where you have the pivot. You have column 3 where the pivot element is present. So columns 1 and 3 become the pivot columns. I hope you have followed. So in this lecture session, we have gone through what a coefficient matrix is, what is an augmented matrix, how to convert any rectangular matrix to an echelon form, and then get the reduced echelon form, identify the pivot elements, and also identify the pivot columns. So I hope you have followed. In the next video segment, we shall solve a number of problems wherein we convert the given rectangular matrix to the reduced echelon form, find the pivot elements and the pivot columns, and also find the solution of a given system of linear equations. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads. And to view all the other videos in linear algebra, do not forget to click on the I button or go through the playlist linear algebra. And thanks for watching.